In this problem, we're asked to first graph the parent graph f of x equals x squared. Then we need to graph the function f of x equals negative the quantity x plus 1 all squared plus 3. So let's start by graphing the parent graph f of x equals x squared. Quickly, I'm going to find a few points on the graph. So when x is negative 2 all squared is 4. Negative 1 all squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So I'm quickly going to plot those points. And hopefully you can see that I'm going to get the graph of a parabola. So I'm going to sketch in my parent graph. Drawing with this tablet is kind of hard, so you'll have to bear with my terrible sketches. So there is my parent graph of y equals x squared. And now we need to look at my function f of x. There are three separate things going on with this function. I have a negative outside, I have a plus 1 inside with the x, and I have a plus 3 at the end. So let's look at what each of these effects does. Multiplying by a negative 1 outside, what does that do to the function? It's outside, so it is a vertical effect. And multiplying by a negative 1 is a reflection. So it's a vertical reflection in the x-axis. Then I have this plus 1 inside, and anything inside is a horizontal effect. Adding and subtracting always shifts the graph, but when it's inside, it kind of does the opposite of what you think. Plus 1 you think would make it shift to the right, but it's going to actually shift it 1 unit to the left. And then finally, we have our plus 3 outside. So this is outside, so it's a vertical effect. And again, adding and subtracting is going to shift. And this one's going to shift the way you think. Plus 3 is going to shift it up 3 units. So now we know the three effects, but we have to do them in the correct order. So let's look at this slide for multiple transformations. They should be performed in the following order. So you horizontally shift first, stretch or shrink next, then reflect, and finally do the vertical shifting. Now, in fact, step 2 and step 3 are interchangeable. They can be done in either order. But it's very important that you shift left and right first and you shift up and down last. Anybody else can be done in the middle. So let's see if we can do that on our function here. So do we have a horizontal shift? Yes, this one has to be done first. And a vertical shift has to be done last. So that means the vertical reflection has to be done as the second thing. So I'm going to shift all my points 1 unit to the left. So you just take each point and go 1 unit to the left. And my new shifted graph looks something like this. Since it's not my final graph, I'm still going to do it in a dotted line. So that shifted 1 unit to the left, the blue graph. Now I'm going to reflect in the x-axis. So what I have to do is, let's take this point to start with, the point on the x-axis. If I reflect it in the x-axis, it's going to stay exactly where it is. This point here was 1 unit above the x-axis. It's going to go 1 below. This was 4 above. It's going to go 4 below. The next blue point was 1 above. It goes 1 below. And the last blue point, 4 above, 4 below. So there is my reflected graph. Sorry for the terrible drawing. And lastly, I have to shift it 3 units up. So you just take all the red points and you go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, and 1, 2, 3. Now this one I'm going to graph as a solid line since it's my final graph. And it's going to look something like that. So that is my function f of x equals negative x plus 1 squared plus 3. Oh, just squeak it in there. So the green graph is my final graph for f of x.